Hey everybody, welcome back to Video Game Esoterica, and on today's episode of On a Technicality, we're going to be talking about how to power your Sega NAOMI or JVS boards with an ATX power supply. Before we get too far involved, you can do me a huge favor, go down below, hit like and subscribe, ring that notification bell, we appreciate it. And if you feel so inclined to like tutorials like this, we've got a Patreon link down there as well if you want to support the channel. But we have everything we need to power the JVS board with that ATX power supply. We got our pin crimpers, our pins, our connectors, our pliers, and that 24-pin ATX cable. And the reason that I do this in the first place is you could totally buy another power supply for your NAOMI and power it that way for the JVS, but I like reusing items because I don't have a lot of space in my house. And you'll see here that the JVS standard uses this 8-pin and 6-pin power connectors, which is totally different than JAMMA. And we have these JST VL plastic connectors that we're going to be converting into the 24-pin ATX power supply. Now when you buy these online, always buy at least 2, because if you put the pin in the wrong spot or something breaks, getting the pin back out of these connectors is near impossible even with the right tools. So don't make the mistake, buy 2. They cost like 30 cents each, have a backup because you will occasionally make mistakes, you don't want to wait for another package to come in. But they slot into the board really easily, they are keyed, so you cannot put these in the wrong way. I guess unless you try the square peg around hole on this one, you'll see there's a little latch at the top, so when you push it in, it locks. So you really can't get this backwards. If it's not going in, trust me, it's not supposed to fit. There's some innuendo there, I'm sure, but it really is easy. So on the 24-pin power supply, the black leads are going to be ground, the yellow leads are going to be our 12-volt supply, and then from there we're going to have the red leads, which are going to be our 5-volt, and then the last cable we need is going to be orange, which is 3.3 volt. But what we also need to worry about is this green wire right here needs to be grounded out, or else the power supply will not turn on. We will show you how to do that further in the video, but we do need that green lead. Around the back, the purple, the gray, and the blue wires are completely unnecessary for this, so we're not going to worry about those whatsoever. And the reason that I like reusing things is this is my super gun set up for JAMMA, but I put the power supply on these double-sided command hooks so I can remove that 24-pin ATX cable from it, and I'm able to install another cable in there. So I can have one power supply, and that's going to let me do multiple things. And they are keyed as well, just like the JVS system. So you can't put the 24-pin in backwards, it's only going to go in one direction. And again, don't force anything, trust me, you're not going to be able to connect this incorrectly. And inversely, on the other side, the plastic connector is too big in both directions, so in the 4 possible configurations you could plug it in, only one works. But taking a look at this extension cable right here, we know what leads we need. So what we're going to do is we're going to come in with a pair of side cutters, something sharp, and we're just going to start cutting those leads. Now make sure you 100% check that you're cutting them on the right side. Make sure you know what side connects to the ATX power supply, because if you cut them from the wrong end, you're done. I could have just bought empty power supply leads, an empty 24-pin connector, but I had this sitting in my drawer from years ago, and I like reusing things versus buying new when I can. So you can do this, you can buy a blank one, buy the pins and wire it up yourself, but this works for me. But you'll see here I've cut all the different wires I need out of that 24-pin power supply, and I've left the gray, the purple, and the blue alone because I don't need those, and now we have everything we need to be able to start wiring this up. But you'll see we have a situation where we have more power leads than we have pins. What I'm going to do, NAOMI is touchy and it can sometimes restart or fail to boot a game if you don't have proper power. So on some of the connectors, I'm going to wire 2 leads in tandem into one pin. But the first thing we need to do is use our wire strippers. This is 18 AWG gauge wire. So we're just going to start taking a little bit of the insulation off. Now you don't need much. You don't want too much wire exposed, and I will show you in the next shot exactly what you need. But getting the insulation off can sometimes be difficult, but just make sure you're on the right gauge, pull, and eventually that will pop out, and we're going to need to do that for all the wires that we need. Now when we take a look at the pin, you'll see that wire I have exposed. The front jacket, there's 3 parts. There's the pin, there's the middle, and then there is the left-hand side. The left-hand side is just going to grip the insulation. The middle is what's going to crimp onto the wire. So you want to make sure that the insulation doesn't go to the middle, and you want to make sure the wire doesn't go behind it. This looks good right here. And basically what we need to worry about on this is green and black need to be connected. If you don't ground green, your power supply won't turn on. With the schematic here, we know, looking at the front of the board, where our 3.3, our 5 volt, and our ground signals go, and on the 8-pin connector, we know where those signals go as well. And I will say, not all the grounds are necessary. I don't put a ground in pin 4 on the 6-pin connector, or pin 5 on the 8-pin connector. That's how the NAOMIs came wired up from the factory in cabinets, so I don't really worry about it. I know how many grounds I have, I know how many leads I have for everything, so I know where all my signals are going and how many wires I need to worry about when I'm doing it. And you'll see here what I'm doing is I'm taking 2 of the orange leads, that 3.3 volt, and I'm going to put them in a pin together. But when you're putting more than one wire together, you always want to make sure you try to pick something close to it. I don't want to take one orange from each end of the 24-pin ATX cable, because that's going to put strain on the cable. So I take the 2 orange leads that are next to each other, and I'm going to put both of those into one pin. That way, that voltage is going to be supported by more than one pin coming out of the power supply. And since crimping pins is a pain in the butt, I have a video that I've done before. I will leave a link below. I use these needle nose pliers to come in and just pinch that little retention arm around the jacket, and it fell off. Easier off camera, but do that, it'll stay. And you'll see now that I have 2 different 3.3 volt leads going into one pin for the NAOMI. This is just going to give us better power draw, more consistent power draw, because like I said, it'll restart. And make sure you buy more pins than you need. You're going to screw up when you put 2 leads into one pin. It just happens. But what we're going to do now is just come in with our continuity meter, and we're going to put one probe into that pin that we just crimped, and then we're going to take the other end and probe both of the lines that we put in. We have continuity on both, so we know that crimp's good and it is ready to go into the NAOMI. Now that I have all of those different leads crimped for the 8-pin connector, we're going to be able to install them into that JST VL connector that goes into the NAOMI. And putting them in can sometimes be a little bit of a pain in the butt. It is tricky. Once you get them in, trying to get them back out is extremely difficult, if not impossible. That's why I say buy more than one. But these are keyed as well. You can only put the pin in one direction. If you're pushing and it's not going in and you don't hear a click, all you need to do is spin it around 180 degrees, make sure you're still putting it in the right pin, and all of a sudden it'll click in place and it's locked in there. And now that I have that in, I'll just check my continuity one more time to make sure that everything is good. I test it each stage, that way when I actually get to the point where you plug this into the wall, I know 100% nothing could be wrong. And now that I've filled that entire 8-pin connector, I know that I'm ready to go, but I will still just come back in one last time and check continuity on each of the pins, making sure they're going exactly where I need them to. Because once you plug this in, if you are wrong on anything, you see magic smoke and it goes poof. All my leads are taken care of. And what I did for the power on signal, I just took that green lead and I crimped it together with a pin, so I have that cold solder joint. But because that is exposed, I will just come in with some shrink tube and I'll measure how much I need, just so I'm not wasting it. They don't give away shrink tube. It's not the most expensive, but it's not cheap. I'll just come in with my side cutters, pop a little bit off, and then slot it over that and just use a lighter to shrink it up. That way it can't ground out to anything additional. This is going to be perfectly fine. I could have installed a switch here, an on-off switch, versus just, putting them together, but I'll show you why I didn't do that in a moment. And because I couldn't fit 3 leads into one pin, I have one stray 5-volt line, and if it's not plugged into anything, it's not going to really draw power, but we don't want it touching anything, so I'll come in and just use the same heat shrink tube, just a smaller gauge, to cover that so I know it's not going to touch. But now the entire harness is made. We have our 8-pin connector, we have our 6-pin connector, and we have the green power signal line grounded out to an additional ground. So when I plug this power supply into a wall, it'll instantaneously turn on and be ready to go. And you'll see here, everything is set up. Now in hindsight, I wish I had made something new versus using a part I had in my drawer, because I'd like a little more distance between the power supply to the NAOMI. But like I said, I reuse as much as I can. Things are expensive and this is cheap or free to me, but if you do this, maybe you want a little bit of a longer run. And with the reason I didn't put a power switch in here is that I always use a power strip with a switch. That way I can plug everything in and there's no power going to anything. And then when I put the power switch on, that's when power comes. So putting a power switch in line would just be one extra step. When I turn it on, the fan spins up on the power supply, the fan spins up on the NAOMI, and you can't really see it through the grate near where it says NAOMI, but the red light is on, and we now have power to the entire system. But I can't stress enough, follow the pin out entirely. So when you're getting power from the wall, if those pins are incorrect, you will blow the board. You don't get a second chance at this. So the number one thing is just keep track of what voltages you're sending to what pins. But that's how you power a Sega NAOMI with an ATX power supply. If you have any questions, leave them down below. If you want to do this yourself, I'm happy to help. But like I said, just be careful when you're dealing with power. You're not going to really electrocute yourself, but you can blow a board up if you don't send the right voltages to the right places. But again, we really appreciate you watching this. Hopefully it helps you guys out. If you have any questions, leave them below. Otherwise, we will be back next Friday with more videos, and we have one on Sunday and Tuesday as well. But like I said, do me a huge favor, go down below, hit like and subscribe, and we appreciate it, and have a great weekend. Bye-bye.